So this is my new SlimBlade Pro Wireless mouse that I purchased over 3 months ago. I've been using it exclusively on my right side to great delight. It's my favorite trackball of all. Over time, I noticed that the trackball gets kind of sticky and gummy. There's a term people use called STICTION, which means there's a resistance to starting, which results in either kind of a sliding effect or a very annoying resistance, like a hard resistance that you feel right before you start your ball. And because trackballs are start and stop type of thing, it gets extremely annoying. With my Kensington Expert with Silicon Nitride bearings on my left side that I use at the same time, the stark difference in smoothness between the two becomes increasingly noticeable. I found myself silicone lubricating my right SlimBlade Pro constantly, like every day almost, to make it acceptable compared to my Expert. After a while, I finally decided I need to open this thing up and change out the bearings. I was fearful of doing this because for the longest time, you couldn't get one of these. They were sold out, and a couple of months of wait was what Kensington people said. And so I was worried about messing it up. But now that they're available again, I'm going to freely open it up, as you can see. The opening process is very similar on the outside to the old wired, the cabled SlimBlade. Each of those pads at the bottom at the four corners hold a screw, and screws are held in the central ring as well, on ring pad at 120-degree intervals. And then you just take a pry bar and just carefully wedge it open like that. Once open, I found that the internals were shockingly different compared to the old SlimBlade. The frame, the casing system was different. The screw placement, everything was different. It did use cable connectors still, 2 of them, but now it had these kind of awkwardly placed hardwired connectors with the 4 prongs, as you can see. I did try to pull those apart, but they were in there hard, and I didn't want to crack the plastic. I didn't need to open them up anyway because I wasn't going to replace anything there, so I just kept it on, as you can see, which makes viewing my work very awkward, and unscrewing the main board also very awkward. The main board, as you can see, does need to be unscrewed off because you have to screw out 3 of the, I think it's a 1/2 centimeter flat large screws under which are the ruby bearings, one of which I'm removing right now, as you can see. So that one unscrews out easily, and so does the other one at 120 degrees, but the third one is underneath one of the lens controller boards, and so to get to that, you have to unscrew the main board, unfortunately. I mean, it's not a big deal. It's just 3 screws holding the main board down. Now, as far as the bearings go, I've tried 3 different bearings: the ruby bearings, the zirconium dioxide bearings, and the Silicon Nitride G5 bearings. And of the 3, the Silicon Nitride G5 bearings are by far the most superior. This is the SI3N4 chemical designation, and this is the one. The silicon nitride is one of the material used, a crystalline material used as a bearing material professionally. You know, this is the ball bearings used on the space shuttle, for instance. You know, all the engineers there had the full range of material available to them, and this is what they chose because silicon nitride is very, very hard with a Mohs hardness of 8.5. 8.5 is harder than hardened steel. It's harder than cubic zirconium, but it's not quite as hard as like titanium or, of course, diamonds and rubies. The ruby bearings that is provided is true synthetic ruby because I shined a UV light on it and it does glow under UV light, so it's real ruby. But for whatever reason, it develops this kind of gummy traction over time, and it causes that stiction and resistance. I believe the surface of it must be quite rough. I don't have an electron microscope or anything like that to prove it, but just by feel, that's the sense I get. It's less smooth than cubic zirconium. Zirconium dioxide bearings that you can get. And I've tried that on my huge number of Elicoms. I tried it on the original Kensington SlimBlade as well. They're very much smoother than the ruby provided by Kensington, but I think it's a much more subtle difference compared to the silicon nitride. Now, silicon nitride as well as zirconium dioxide are in the class of what they call ceramic bearings. The zirconium dioxide tends to be used as a coating material on objects, whereas silicon nitride is purpose-made to be used as bearings. Now this thing, I'm going to knock it out using the point of this wooden mini clothes hanger thing, whatever I have, so I don't scratch up any of the material, plastic as well as the, I wouldn't scratch it up anyway, but because I had so much silicone grease on it, it was quite sticky and stuck inside the bed, so I ended up having to use the point of a screwdriver, as you can see, and it sticks to it because of all that silicone. So there it is. So I'm going to preserve the ruby bearings because they do tend to be expensive, and I could reuse them again should, for whatever reason, I need it again. But silicon nitride is very inexpensive. I would recommend buying it from eBay. On eBay, if you do a search for, what is it, silicon nitride or Si3N4 bearings, you'll find that they're available in China, from China, for like $6 for 10. It's the same thing for zirconium dioxide ceramic bearings. You can get those for about $6 shipped if you just search for zirconium dioxide bearings specifically. But as you can see, quite easy to place, and there it is. Silicon nitride. Nice and glossy black. And so I didn't need to take apart this casing like this, but I was just curious what it looked like. And you just have to refit it carefully. And it's screwed down by 4 points, 3 in the back and 1 in the front. And then it's screwed down to that black gleaming plastic ring with 4 corners screws. So once that is on, as you can see, it's just a matter of re-screwing everything back together. So once I did this, I saw, shockingly, that the switches on these were quite different, as you saw. I'll put a picture of it so you can look at it closer at the end of this video. The old ones used Panasonic EVQ P0E07K tactile 0.05 amp 30 volt switches, which were these small squarish, or I guess cubical switches at each corner. these new ones are large, elongated rectangular switches. I have no idea what these are. You could try calling Kensington at 800-535-4242, but I haven't had much luck getting them to answer simple questions like that. But I wish someone else would try it. Last time I did desolder and resolder new switches onto my Kensington switchblade, but it never quite worked the same. So I didn't want to mess this one up just for fun. But the switches are quite different from the Expert. I can see how some people might say the old Expert switches are superior to these, but these have their own unique feel, and I think they're fine. You sometimes do have to press down a bit harder on this one than with the Kensington Expert, but that's just the way it is for now. Now, overall, I tried to disassemble this SlimBlade Pro Wireless with minimal damage to it, and I tried to disassemble it as carefully as I could, but I would say it's fairly easy. The only weird part about it is that once I put it all together, I couldn't get the two halves of the casing to fit flush with each other. I don't know if something was holding it down. I looked in it carefully inside in several ways, but the only way to have it flushed up against each other was to screw the four corners and the central ring screws all the way down, and then it would fit flush. So besides that, everything was pretty smooth as far as the disassembly, reassembly of this unit, and everything worked fine. All the switches, all the combination switches I had programmed in, the DPI switches, the Wi-Fi to Bluetooth to off switches, and of course the trackball functioning, movement, everything was fine after I reassembled it. So it's a little minor project that I think anybody could do in about an hour or so if you have the right tools. I think that once I had the silicon nitride bearings in place, and you'll see this, when I first started trying it out, I was just shocked at how much smoother it was compared to the Ruby bearings. I estimated subjectively about like 33% smoother, but it could have been more. I'm sure there are methods to quantify this, but I know that the original materials data sheet for silicon nitride bearings, it states that it has 80% less friction than steel bearings. Steel bearings actually are used by some enthusiasts for whatever reason. I mean, a lot of them use that BTU, BTU steel units to make it a bit smoother. But no, steel bearings are very rough compared to these silicon nitride bearings or compared to zirconium dioxide bearings. They can be loud, coarse. I think they definitely have more resistance unless you lubricate it with oils. I mean, unless you're into some kind of vintage steampunk type of thing about it. And I don't see any reason why you should be, because you can't see it. You can only feel it. Steel bearings, I think, are inferior in every way to silicon nitride bearings. So as you can see, it's a bit clumsy to get in there with screws. And here I'm having trouble getting it to fit flush. And after investigating a little bit, I just said, oh, screw it, literally, and I started just screwing it together, and then it's fine. And so this ends my video disassembling, replacing the OEM Ruby bearings with ultra smooth 2mm silicon nitride bearings imported from somewhere in the Hong Kong area of China, reassembling my trackball.
To the United States. You can't implement. So one of the problems with it is
I just had to show my new
that's
device,
what geniuses
my
are.
Makita blower.
Geniuses are basically certain
So there.
a combination of
There,
factors,
I turn it on.
seems to me, which often
Here,
don't go together.
my first
So
run,
high intelligence
testing
plus
all the switches.
and antisocial traits. Some
Absolutely
limited extent antisocial traits.
glorious
Some
feeling,
traits,
smooth,
ADHD,
smoothness beyond
that come up with something
words.
positive. And I don't artificially replicate what.
So, thank you for watching this video.